In this lecture, we'll be talking about introduction to a system of linear equations. Just to avoid these systems of linear equations, sometimes we make it short and we say linear systems is exactly the same. Okay, so if you hear linear systems or if you hear systems of linear equations, we are basically talking about the same object. So let me start with an example that is inspired from economics. Okay, so example and motivation. And I wanted to have it from economics to give you an idea how it's not about pure math. It's not about sometimes these linear systems you can see them in different areas. In fact, economics offers a wonderful example where, as I said before, in the motivation or in the welcome, that the number of unknowns when it comes to economics is huge compared to some problems related to physics, for example, where you may have sometimes three, maximum four unknowns. Okay, so let's say you have a $10,000. So the original amount is $10,000, and we want to invest this $10,000. Okay, so we want to invest them, and we have two types of investment. One is to put them in stocks, put money in stocks, and the other one is in bonds. So what's the difference? This is a very, very beautiful problem that many people, including myself, because of my age, do face. Okay, and young people do not, in general, pay attention to this. Okay, so what's the difference between investing money in stocks and investing money in bonds? In a very, very simple way. I don't want to go into this. Not a course about economics and investment, but it's just like an idea of what is the main problem that is faced when we're investing either in stocks or in bonds. So the difference is that the stocks, they usually have a good return, okay, a better return, annual return, okay, and the problem is that the risk is higher for the stocks. Okay, so you have a good return, but at the same time you have a higher risk. In other words, the money can go up and you can lose it quickly. Okay, as soon as we have a major problem, then the stocks, they tend to go down, while bonds is slightly different. Okay, meaning what? The return is small, but the risk is smaller as well. Okay, so we usually take a rule, the following rule, that when you are young, you want to put your money in stocks because it's a long-term investment. When you get older, like me, then you want to put less money in the stocks and more money in bonds. Okay, so when I say, for example, that I want to invest this $10,000 and I only want to have 5% return, okay, at the end of the year, keep in mind, one will say, why do you want just to have 5% if putting $10,000 in stocks will get you a higher return? Yeah, it will get me a higher return, but there is a risk that I may not get anything. I may lose my money. So that's why you have to balance it, in other words, okay? So I just want 5%, something in between what bonds return in general and stocks return. These days, by the way, I'm talking about. So 5% is not a bad return. Of course, if you are aggressive, that's a different story altogether, okay? So let's go to stocks, and let's say, for example, for the sake of argument, that we're getting a 10% annual return, okay? While the bonds will give me only a 1.5% return, okay? So keep in mind, I just want, this is the goal. The goal is I'm satisfied if I can get a 5% return on my investment, okay? So I'm putting $10,000 and I just want 5%, okay? So the question becomes, okay, so how much will I put in stocks and how much will I put in bonds? So let's say, for example, so now we want to model the problem into a math problem. And this is not a course about modeling, but usually we take we assign the unknowns or the variables some letters, okay, to symbolize them. And one way to do it in modeling is the initial of the word is, for example, volume, it's a V, pressure, it's a P, temperature is a T, time is a T, etc., etc. So here, stocks, we're gonna call S the amount, okay, amount invested in stocks. And B is the amount invested in bonds. Okay, so now what do we know? We know that first, equation number one is so simple. So we have equation number one, which is that S plus B is equal to 10,000. That's the total amount I'm investing. So the S plus B is equal to 10,000. And now what about the return? That will give me equation 2. This has to do with the return, okay? So I want 5% of my 10,000, meaning what? That 5% of 10,000, that's $500. So that's what I want at the end of the year. So how much will S return to me? So as we said, it's 10%, okay, the stocks. So it's gonna be 0.1 times S. That is the amount stocks are returning, the amount of S dollars invested in the stock will return, okay, 10%. Plus how much the bonds are returning, 1.5%, which is 0.015 times B. That's the amount that the bonds, the amount invested in bonds will return. So if I add them, that will be my total return, which I want it to be 5% of 10,000, which is 500. So that's what I want. So that's my second equation. So basically, I want to solve, okay, which I will clarify in a second. Basically, I have two equations, S plus B equal 10,000 and 0.1 S plus 0.015 B equal 500. Okay, so what is S and what is B? So first of all, S and B are unknown. Is that clear? Okay, so we're dealing with a system of two equations where I have two unknowns, S and B, unknown, okay? And my goal is to find out their values. In other words, to make them known. They are unknown, and we want to make them known. So this idea is fundamental whenever we're dealing with problems in mathematics and in science in general that involve an unknown. Okay, so one of the most beautiful problem in economics is the problem of the price. What is the price of something? Okay, and this problem of finding the price of something is so important in economics. For example, what is the optimum price for a barrel of oil? Under certain constraints, of course. Okay, it's not like a simple problem. It's a very complicated problem when you have so many constraints. Okay, so anyway, the point here is that to make S and B known, okay, this is known as finding the unknowns or solving the system. So I will say something later on about this. And so in order, just I said this is an example and the motivation. So let's not use S and B. What are the generic letters in math for the unknowns? Okay, X when you have one unknown, but if you have more than one, so we get X, Y, Z, etc., etc. So in this case, we're going to use X and Y. So we'll put X equal to S and y equals to b. So my system becomes x plus y equal 10,000 and 0.1 x plus 0.015 y equal 500. Okay, so I'm not gonna discuss it here, but for the sake of argument, just for the sake of argument, let me just tell you that x, which is s, is equal to 4,117.64, and y equals to b, the amount of money invested in bonds, is 5,882.35 cents. So in this case, the system has what? One solution. Okay, because once you make them known, okay, the known numbers associated to x and y are called a solution. We'll talk about this later on. I want just to give you this example. Okay, so this is an example of what is a linear system. What you see right here okay, is an example of what is a linear system. Okay, so in order to move on, I'm done with the motivation. Now let's go into the abstract formulation, okay, of what is a linear system. So now we start by what is a linear equation to start with. Linear equation. Okay, because a system of linear equations is just a bunch of linear equations. So what is a linear equation? So let me start with a few examples, okay, and then we move on from there. So first, if you have two unknowns, x and y. I'm using generic letters for the unknowns. So a linear equation in this case is, okay, so a linear equation is of the form ax plus by equal to c. Okay, and this reminds us what? Of course, we're assuming that a and b are, and c are not all equal to 0. And this reminds us of what is a line, okay, the equation of a line, okay? Of course, there are different types of equations, but I'm talking about the general one, because if you take, for example, the slope equation, once you use the slope, you are losing the vertical lines. But in this form, you get all the lines on the plane, okay? And I'm assuming that a and b and c are not equal to 0. Otherwise, what's the point, okay? If c is equal to 0, okay, we say that the equation is homogeneous. Okay, so now what happens when you have three unknowns? X, y, and z. Okay, so in this case, the equation is the linear equation becomes a times x, b times y, c times z equals to d. Same argument, d equal to 0 gives us what's known as homogeneous equation. So whenever I use the word homogeneous equation, I mean d is equal to 0. Okay, and I'm assuming, of course, that a, b, c, and d are not all equal to 0. Okay, so this in this case is the equation of a plane in R3. Okay, this is the equation of a plane in R3. So what is now a linear equation? A linear equation with n unknowns. Now it becomes interesting. So again, before I said ax plus by. Let me go back. So ax plus by equals to c. Then it became what? Ax plus by plus cz equal to d. I can still handle 4 unknowns, 5 unknowns. What happens if, as I said in economics, where you have large number of unknowns, what happens when n is large? And therefore, it's not appropriate to use x, y, and z. What we are going to do is use the generic letter, which is x. So in this case, we will use, okay, x1 for the unknown, x1, x2, x3, xn. Because if n is large, then there is no way you can use all the letters. Even if you use all the Greek letters, the Latin letters, and any other letters, including the Arabic letters, it will not be enough, okay, when n is large, okay? And there are systems that in economics that involve huge number of unknowns, okay? So in this case, the numbers that you have in front of x1, I'm talking about a, b, and c in the equation that you see there within the green area, the same. I cannot use a, b, and c. So what we are going to use is a1. So the equation, sorry, the equation. So the linear equation now becomes okay, a1 x1 plus a2 x2 plus etc. an xn equal b here, okay? So homogeneous linear equation, if and only if b is equal to 0, okay? So now in terms of terminology, we need to agree on some terminology. It gets complicated, huh? It gets complicated, but in terms of terminology, a1, a2, an, we'll call them the coefficients. Huh? So a1 is the coefficient of x1, so you have this concept of coefficients. Okay, so a1 coefficient of x1, etc. So a2 is the coefficient of x2, and an is the coefficient of x. Be very careful when you have a minus, it goes inside the coefficients a1, a2, an. Okay, students usually they tend to forget about that. Okay, in any case, and also, by the way, b is called the non-homogeneous term as well. Okay, but these are just few terminologies. Okay, now that we define the concept of a linear equation, what is a system? So here, what is a system of linear equation? It's clear what it is. So it's that you have a bunch of linear equations, okay, and you put them together. So basically, a system of linear equations is a certain number of linear equations together, okay? So instead of having one, you have multiple ones. And usually, let's say, for example, m is the number of equations. So in a system of linear equations, there are two numbers, very important. N, the number of unknowns, and m, the number of equations. So we have two numbers that you always have to pay attention to, okay? So usually we have two numbers, the number of unknowns and the number of equations. And everything is possible, meaning what? That the number of unknowns can be larger than the number of equations. The number of equations can be smaller than the number of unknowns. Okay? I'm sorry. Number of unknowns is larger than the number of equations. The number of unknowns is smaller than the number of equations. Or the number of unknowns is equal to the number of what? of equations. Okay, so this is all possible, by the way. Okay, and in all practical matters, very rarely this or at least in myself, deal with large systems, meaning more than, for example, 2 and 3 unknowns. Once you get the idea of what's going on with 2 and 3 unknowns, then you can imagine easily what can be done with more than that, 5, 10, and 100. Okay, so remember what's the goal. The goal is to make the unknowns what? Known, or solving the linear system of linear equations. Okay, so how do I write this system? First of all, before I write the general form, let me give you some examples. Okay, example of linear systems. Okay, so if I take, for example, this one, 2x minus 2y equal 1, and 3x plus 2y equal 0. Okay, so what are we talking about here? We have two unknowns, so n is equal to 2, and two equations, m is equal to 2. Okay, what about the following system now? Okay, which is 4x minus y plus 3z equals 0, and 2y plus 5z equal to 1. So in this case, we have three unknowns, n is equal to 3, and two equations, m is equal to 2. Okay, so this is just to give you an idea of examples, and I'm pretty sure you can easily come up with examples of systems, linear systems, with n unknowns and m equations. Another idea here, or remark, okay, sometimes this is very important, because sometimes, and this is very common to the students, they jump on any system and they treat it as if it were a system of linear equations. So be very careful. All the techniques that will be developed, okay, to solve the systems of linear equations, meaning making the unknowns known, not all the systems are linear. So before you jump in with a certain specific technique, okay, you need to make sure that you are dealing with a linear equation. For example, if you take sine x, just as an example, sine x plus y equals 0, okay, or square root of x1 plus 2x2 minus x3 equal to 1, etc., etc. These are not linear equations. We call them nonlinear equations. The problem becomes extremely complicated to make the unknowns known in this context. Okay, so remember, we are dealing with linear equations, and we gave the form of a linear equation. Okay, so whenever you have sine, cosine, ln of x, es of x, none, or square root of x, any other power, 1 over x, for example, these are not linear. These are nonlinear equations, and they are not part of the course I am discussing here. Okay, so great. So another object, and before I do that, let me. I want to go back to the concept of a system. Okay, and I want to say something. When we put in this linear equation. Okay, so this is a linear equation, and what's interesting is, what did I say about A1? Okay, for example, I mean, of course, the same argument works for A2, for A3, for AN, but what is the meaning of A1? A1 is the number, the coefficient of x1, the number you have in front of x1 in this equation. And what is A2? Is the number that you have in front of x2 in that equation, etc., etc. So what happened in that equation? Huh? What happened when you have many equations? Then one has to be careful, okay? So let us go, for example, to this example, this one here. Okay, so if I tell you the coefficient of x, you cannot say 2, And you cannot say 3. Why? What's missing? What's missing is the fact that what equation are we dealing with? Yeah, you are dealing with the number in front of the unknown x, but in what line? In what equation? So here we have a new dimension. So in other words, we have the numbers that are in front of the unknowns, the position of the numbers in front of the unknowns, okay? And the position of the unknown as well as its coefficient in the equation. So for example, in this case, in this example that I'm looking at right now in pink, the first equation, we'll call it, is the one that you have at the top, 2x minus 2y equal 1. And the second equation is 3x plus 2y equals 0. Therefore, what is the coefficient of x? This question by itself cannot be answered. So what we have is the coefficient of x, the right question, the coefficient of x, or the number in front of x, where? In the first equation or the second equation? Okay, great. So now let us consider that x is the first unknown. Okay, because that's how I wrote here in this equation, x1 is the first unknown. Okay, x2 is the second unknown, and xn is the nth unknown. And we have to be careful, because if I want to discuss the concept of solution, I need to be very careful. What is the first unknown, second unknown, third unknown? It's like before in the motivating example, x was S, which is the number of amount that we are investing in stocks, and y was B, the amount of money we are investing in bonds. So here anyway, so x is the first unknown, and when we say the coefficient of the first unknown, one has to ask, is it in the first equation? So we have the coefficient of the first unknown in the first equation. In that case, okay, the answer is this one. So the coefficient of the first unknown, x, in the first equation. What about the coefficient of the first unknown in the second equation? Okay. Do you see it? Is this. So this is the coefficient of the first unknown in the second equation, etc., etc. So for example, if I tell you what is minus 2 is the coefficient of the second unknown y in the first equation. So you see, the position of these coefficients depends on two numbers. First, in front of what unknown, two, in what equation. Okay, so as you can see, these numbers, these coefficients now are collected and cataloged in two-dimensional direction. Okay, so this they give birth to a concept in mathematics which is fundamental, which is the concept of matrices. Naturally, huh? So the concept of matrices. So these are two-dimensional data, two-dimensional data. Okay, so let's look at the example that we have here. Example. So we said 2x minus 2y equals to 1, and 3x plus 2y equals 0, for the sake of arguments. Okay, so what are the coefficients? So we have the first one, so the first equation, the first equation we have 2 minus 2, and do not forget number 1. Okay, these are the coefficients. So the first number 2 is what? Is the coefficient in front of the first unknown in the first equation, minus 2. The coefficient that we have in front of the second unknown in the first equation. And 1, the meaning of 1, is the non-homogeneous term, right? Great. What about the second equation? 3, 2, and 0. Okay? So, and of course, 1 and 0, okay, are the non-homogeneous terms. So this known as augmented matrix associated to the system. Okay, it has all the coefficients, and it's really interesting because you will see later on we can program it, we can work with it without knowing what symbol for the first unknown and what symbol for the second unknown. It's really amazing. It can be any letters you want to use. Okay, especially when you are dealing with with huge systems. You have these numbers in this augmented matrix. It captures very well the system. Okay, and you don't have to assign x1, x2, x3. So as you can find it, you will see later on what I'm talking about. Okay, so let's look at another. I want to look at the other example just for the sake of example. Let's look at the other system. 4x minus y 3z equals 0, 2y plus 5z equal 1. So the augmented matrix is going to be what? The augmented matrix for the system will be, so two equations, two rows of data. So the first row, what's the coefficient of the first unknown? X is 4. What's the coefficient of the second unknown? Y, minus 1. What is the coefficient of the third unknown? Z, number 3. And what is the non-homogeneous term? 0. Okay. Okay. Now what about the second equation? What is the coefficient of the first unknown? X. None, because we don't see it. That means you have 0. 0 times x. Okay. What about the coefficient of the second unknown y in the second equation? Number 2. And what is the coefficient of the third unknown z in the second equation? Number 5. And what is the non-homogeneous term? It's 1. So as you can see, we have the size of the matrix. So what is the size of the matrix? The size of the matrix. Okay, of the augmented matrix, of course. I'm talking about the augmented matrix. Okay, so what we have how many columns? So we have the columns are exactly the number of unknowns plus 1, because you have that non-homogeneous business. Okay, so in this case we have n plus 1 columns. And what about the number of rows? This is exactly the number of what? Equations. So m is the number of rows. Okay, so this is the case. I want just to add something here. What happened when very important to separate between the coefficients and the non-homogeneous terms. So the coefficients, when if you take only this matrix here, okay, this has a name and it's called the coefficient matrix of the system. So, and the same here. Okay, so if you have only you ignore the non-homogeneous term, then in this case, so for example, if you go back here, what would be the size of the coefficient matrix? So the size of the coefficient matrix is going to be only what? N for the number of columns, the number of unknowns, and M, which is the number of rows. Okay, so the number of rows is the same, but except that you have one more column for what? For the augmented matrix. And augmented matrix, how do you know the difference between, if I give you a matrix, how do you know? Okay, let's say for example, I forgot, I'm giving you 1, 2, minus 1, 0, 1, 3. Okay, if I say this, how do I know that it is augmented matrix or a coefficient matrix? If you see that they put here something to separate what? The last column from the previous one, that is the augmented matrix. So this will be the augmented matrix. If you don't see this and it's not done, it means it's the coefficient matrix. But sometimes you have to be careful, because sometimes the people will forget to put that dashed line to separate, or a line, straight line, to separate between what? between the non-homogeneous terms as well as the coefficients, okay, to separate them. So if they forgot, you need to ask, do we have the augmented matrix? You ask, somebody gives you this, you say augmented matrix or coefficient matrix. So it gives you an idea, because it makes a big difference. For example, if you look at this, if this matrix that I'm giving you here is a coefficient matrix, this means that you have 3 unknowns and 2 equations. But if it is an augmented matrix, it becomes 2 unknowns with 2 equations. Okay, so one has to be very, very careful when dealing with this kind of problems. Okay, so in general, okay, so general form. Okay, so because we have n unknowns and m equations. Okay, so in general, okay, this is general form. Okay, so I'm not going to be able to use what? So we are going to use a1 x1 plus a2 x2 plus an xn equals b. Yes, that was the general form of a linear equation with the n unknowns. But keep in mind, if I have a system of m equations, okay, then I have different equations. So what we do, we put 1 here, meaning the first equation, 1, 1, and b1 is the non-homogeneous term. So what about the second equation? It's going to be a 2 1 x1 a plus x1 plus a 2 2 x2 plus a 2 n xn b2. This is the second equation. And if we go down, the last one would be m, the mth equation, am1 x1 am2 x2 etc. till we reach amn xn equal bm. This is what the system. Okay, so aij. So now what's the meaning of aij? aij, what's the meaning? So this is the coefficient of what? Remember, am1 x1, so j gives me the unknown, so of coefficient of xj, where in the first number gives me what? The equation. So in the equation I. Okay, so it's very, very interesting. So now what about the 2 coefficients? So let's say the augmented matrix, the augmented matrix. So this will be a11, a12, etc., a1n, and then b1. Okay, and then we go down to am1, am2, am n, bm. And we have to put the separation line for the augmented matrix. Okay, so this is the general form of the augmented matrix, as well as the coefficient matrix. Okay, so now what is, just to say a word before I wrap up this, what is the solution? Okay, solution is a bunch of numbers, okay, that a bunch of numbers that if you plug them into x1, x2, xn, you get what? They satisfy all the equations. So for example, okay, so if I give you x plus y equals 2, 2x plus 3y equals 5. Okay, so if I tell you is x equal 1 and y equals 3, a solution. That's a question. So we plug it. So what happened to x plus y? So what is 1 plus 3 for the first equation, x plus y? So 1 plus 3 is 4. It's not equal to 2. And therefore, the answer is no. This is not a solution. You see now? What about if I say is x equal 1 and y equal 1 a solution? Okay, so let's check it out. So we go x plus y, 1 plus 1, that's 2, equals to 2. So the first equation is satisfied, but that's not enough. We need to go to the second equation and check it out. If it satisfies, then it becomes a solution. If it does not satisfy, then it's not a solution. So if we go 2 times 1, 2, plus 3 times 1, 3, 2 plus 3 equal 5, 5 equal to 5. Therefore, the answer is yes. But you see, this here is simple to check if something is a solution. It doesn't tell you, if somebody asks you, solve the system, be careful, huh? Solve the system. That's a different problem altogether. It's very easy to check if something is a solution. It's another story altogether, extremely difficult to solve the system, to make the unknown known, or if you want, find all possible what? Solutions. So this can complicate what? The matter very much. Okay, so before I wrap up this, I want to say something here about what are the concepts that we discussed. Let me put it in a different color to emphasize what I just. So the concepts that we discussed here. Okay, this is one of the things that you have to be extremely careful in linear algebra is to when you are talking and you're saying something, especially a technical name, like for example, solution, like for example, homogeneous, like for example, linear versus nonlinear system. These terminologies, they have to be extremely precise. Otherwise, you have a problem. Okay, people will be lost when you're talking to them. So what are these concepts that we? So number one, what is a linear equation? Number two, what is homogeneous linear equation? Number three, what is a system of linear equations? Okay, so it's more than one. Okay, number four, what is a solution to a system? Number five, okay, is solving a system. Okay, which means that you want to make the unknowns what? No. So all this terminology are very important, and hope that this little introduction, because next what I want to discuss is how do I solve basically a system. Okay, and we want to find the unknowns. Okay, so remember, checking that something is a solution is the easy part. Finding the unknowns is the hard part. But before I let go with this, you see, we said first unknown, second unknown, third unknown, etc. So we have this bunch of numbers. This happens when we say that something is a solution. Okay, when we say something is a solution, like here, I said 1 and 3. But you see what I did here? I wrote x equal 1 and y equal 3. Because what if I told you, check that 1, 3 is the solution? So the question becomes, is x equal to 1, y equal to 3? Or x equal to 3, y equal to 1? So to avoid all these problems, in my system, in a natural fashion, as you see it, x is the first unknown and y is the second unknown. So when I say check that something is a solution, what I will do, I will give you 1, 3. and they say, is it a solution? So what does that mean? It means that the first number 1 is for x, the second number 3 is for y. So we have what's known as ordered numbers. So we put an order, first, second, etc., etc. Sorry. So here we have this concept of, let me put it differently, just ordered numbers. We put an order on them, ordered numbers or tuples. Okay, so we call them, let me just give you an example, very simple. So if I say A pairs, B pairs. Okay, so A is the first number, B is the second number. If I have triple, so we go A, B, and C. Okay, and of course, what if I go for more, like for example, n unknowns? So in this case, I have to go with x1, x2, xn. We call them n tuple. So you have the first unknown, second unknown, and so this way, if I say, for example, 1, 2, 5, I mean the first unknown, I'm going to give it the value 1. The second unknown, I'm going to give it the value 2. And the third unknown, I'm going to give it the number 5. These numbers, they belong to the set, what we call R2. Okay? Of course, if my numbers are real, okay? And R3 and Rn. Okay, so when we put an order, so remember the first R2, these are the coordinate of a point in the plane. ABC is a coordinate of a point in space, etc., etc. Okay? Thank you, and wait for the next one about how to solve the system.